In this video, we are going to talk about the derivative of a polynomial function and chain rule. We'll be covering over the first principle, for the 5 rules, the difference between Lagrange notation and Leibniz notation, chain rule, and one example of a problem using derivative. Derivative is a way to represent the rate of change. The derivative of a point measures the steepness of the graph of a function at that particular point on the graph. This brings us to the first principle, which is f prime x equals lim f bracket x plus h minus f of x over hash. Hash is not equal to 0. Here's an example of how to use it. Fx equals to c, and using the first principle, f prime of x equals to lim fx plus h minus f x over h equals to lim c plus h minus c equals over h equals to c minus c equals 0. Therefore, the derivative of a coefficient equals to 0. This is the constant rule. These are the other 5 rules of derivatives of a general polynomial function: the constant rule, power rule, sum rule, difference rule, and constant multiple rule. The constant rule we've already covered, f of x equals c, and the derivative of f prime of x equals to 0. The power rule is to differentiate a function with an exponent. So f of x equals x to the power of n, and the derivative of is f prime of x is equals to nx to the power of n minus 1.
The sum rule and difference rule are similar. Addition or subtraction of two functions and differentiating them. So hash of x equals f of x equals g of x, and the derivative of hash prime of x equals f prime of x equals g prime of x. Lastly, the constant multiple rule is differentiating a function with a coefficient. The coefficient can be ignored when differentiating the function. So f of x equals c g of x, and f prime of x equals c g prime of x.